Welcome to day 2 of Unit 5, Section 5.3, Integration by Substitution. Today's lesson is rather short. It's just introducing a technique of integration that you're probably going to need to get very familiar with. This technique of integration is used quite a bit in calculus. And as we saw last class, we hope to eventually get to the point where some basic substitutions are done almost mentally. However, you can always rely on using the algorithm of U substitution that I'm going to be demonstrating here for any problem. Okay. So basically, integration by substitution says that if I can think of some function g of x and label it u, and if g of x is a differentiable function and f is continuous on the range of g, this is all things that just need to be true in order for integration of substitution or integration by substitution to work. However, I don't foresee an instance where you would need to check that. So, good to know, not necessary to show. Okay. But basically, this is integration by substitution. If I have some function inside of f, and its derivative appears on the outside, I can substitute u for g. Okay? And I'm going to show you an example here. Okay? Cosine is going to be my f. Then that makes x to the 4th plus 2 my g. Okay. So we'll come over here and let's set u to be x to the 4th plus 2. And then we want to find the derivative of u and see if that appears on the outside of f. Well, the derivative of u with respect to x, of course, is 4x cubed dx. Now, the x cubed dx shows up, but that extra factor of 4 doesn't. So to take care of that, we simply divide both sides by 4 and get 1/4 du is equal to x cubed dx. Now, making the appropriate substitutions, we have a new integral. Cosine of u du. The u was what we decided was inside of cosine, and the 1/4 du came from the derivation of u with respect to x, and then the extra factor of 4 we're taking care of with the 1/4 there on the outside. Now, this is much easier to integrate because the integral of cosine is, of course, sine. So we get 1/4 sine, and the outside, or u was x to the 4th plus 2. Don't forget your constant of integration plus c there. Now we can always check our answer by taking the derivative of this, and we take the derivative of sine, we get cosine, but you have to multiply by the derivative of the inside, which is, of course, 4x cubed plus 0, and then the factor of 4 and the 1/4 cancel out, so I just get the original integrand back. So as you can see, integration by substitution is just the chain rule in reverse. Okay. So we're going to look at 3 more examples today, and again, sort of step by step using this algorithm here. Okay, so let's take a look at a few examples. The first one here we want to keep in mind that u is typically going to be the thing inside of something. So 5x plus 2 is inside of the square root. That's going to be u. However, I don't have a 5 dx there. All I have is dx. So we're going to take care of that by dividing by 5 on both sides. Okay. So substituting things in, 5x plus 2 is u. And dx is getting replaced with 1/5 du. And the integral of u, the square root of u, is u to the 1/2 plus 1 is 3/2 times the reciprocal, or divided by the fraction, is 2/15, and u was 5x plus 2. Don't forget your constant of integration. Okay. Next. This one's a little bit trickier to see. But again, u is typically the thing inside of things. So we're again going to make u 1 plus 4x squared. Du is going to be 8x dx. However, there is no 8x dx in the problem. It's just x dx. So we'll divide by 8 on both sides. Now, let me highlight for you my substitution. U is going here. Okay. And x dx is being replaced with 1/8 du. So the x dx is being replaced with 1/8 du. So if we could rewrite this integral, it's really the integral of u to the -1/2 du, which is a fairly simple integral to integrate now. So we have 1/2 u to the 1/2, or excuse me, 1/8 u to the 1/8. Excuse me, 1/8 u to the positive 1/2, and then multiply by the reciprocal over 1 gives me a 4 in the denominator. U was 1 plus 4x squared, so I have the square root of 1 plus 4x squared all over 4. Don't forget the constant of integration plus c. Now, this one I'd like to go through and double check my answer so you can see really what's going on here. If I were to find the derivative of this, well, this is really 1 plus 4x squared to the 1/2 power, and we drop a half down to the front and multiply by the exponent. The 1/4 now becomes an 1/8, right? And then I get 1 plus 4x squared to the -1/2. Multiply by the derivative of the inside, which is 8x. The The 8's cancel and I end up with x over the square root of 1 plus 4x squared, which is exactly the integrand that we started with. Okay. Don't forget, you can double check your work by finding the derivative of your answer. All right, lastly, good old E, Euler's number. This is an example of one of those problems that you want to be able to do like that. So, let's see. Should be the answer, right? Because the derivative of E is itself. But don't forget that we'd have to multiply by the derivative of the inside, which in this case is going to be 7. And there was no 7 up here. So I'm going to take care of that with a factor of 1/7. So that's my answer. And all I've done is the U substitution in my head, but here's what it looks like on paper. We're going to let U equal 7x. du is 7dx. But there is no 7dx, it's just dx. So I'm going to divide both sides by 7. Now, I can go through and make my substitutions. I'm going to substitute u for 7x and 1/7 du for dx. So I really have 1/7 times the integral of e to the u du. And the integral of e to the u is e to the u, but u was 7x. Don't forget the 1/7. Okay. So an example of one of those u substitutions that eventually we'd like to get to the point that we're sort of doing that in our head. That becomes mental math. That's about it. Again, like I said, short day. See you next time.
See ya.